SQL injection, but it's going to be a bit harder. So these are some of the common techniques to exploit SQL injection. You can also combine them, but there's union operator, error-based, Boolean, out of band, time delay. All of these will work, but in this case, we're going to be combining union and Boolean. And today we're going to look at exploiting blind SQL injection by triggering conditional responses. So what this means is that while the results from our injected query won't be returned to us, but the application will behave differently depending on whether the query returns any data. If it returns data, then something might happen. So true and false. So let's go ahead and take a look. We have the response of this web page, and as you can see, there's this cookie, tracking ID. Now this is the parameter that's going to be vulnerable to the SQL injection, and the reason why we know that is because they tell us in the lab. The application uses a tracking cookie for analytics and performs a SQL query containing the value of the submitted cookie. Nothing's going to be returned, but the application includes a welcome back message in the page if the query returns any rows. So what this means is that we can start testing this, and so we just click send right here. You can see it returns us this page, and we see the welcome back because that tracking ID is true. All right. So what happens if we change that to something that is false? So if we delete this tracking ID, and let's say we put something in like X, click send. Now you see that welcome back message is no longer there. So this is the logic that we're going to be using to try to extract data from the database. All right. For example, let's just add in the OR operator. 1 equals 1. You see, welcome back. 1 equals 2. That is false. Nothing. So this is our win condition here, the welcome back. This lets us determine the answer to any injected command that we put in there. If it's true, then we're going to get the welcome back. If it's false, then we're going to get nothing. So slowly, we can extract data out of this database. All right. So I'm going to quickly showcase an example here. So I want to open up Notepad real quick. So the request, when it's being made, probably looks something like this. Select tracking ID from tracked users, or whatever table it is, where tracking ID is equal to the cookie. Okay. So the cookie would be the correct tracking ID that we saw earlier. So if we put in the correct one, then it's gonna show us welcome back. If not, then it's not gonna show us welcome back. So what happens is when we put in X, right, we close it out, and then we do OR 1 is equal to 1 dash dash. This dash dash here is basically comments out everything that comes after it. So everything here gets ignored. So basically we just see this. Track ID is equal to X, or 1 is equal to 1. And since this is true, the program is going to follow its code and print back this page with welcome back. So let's take a look, and we're going to use a union statement, union query. So we're going to do union select from users where username is equal to administrator. Now we were lucky here that we already knew the table and the columns because the lab told us again. So, but normally you would have to figure that out, which would take a while with this blind SQL injection. So we're going to test this out. We already know the administrator account exists, but for the sake of showcasing, from users, where username SQL administrator, and comment the rest out. So we click send, and we see welcome back shows up on the page, meaning that this is true. The statement is true. The administrator account does exist. So the second part to this is we're going to use the function substring password 11 rather than, let's say, like M or something. Okay, so the interesting part here is the substring, and what this does is it selects a character from the field, in this case password, and we're going to start at the position of 1 and the length 1 for the output. So we're going to see if this is greater than the letter M. Now, depending on the result, it'll show us which half of the alphabet the first letter of the password is in. So we're going to test this out here, and substring password 11 greater than M. Okay, click send, and we do not see the welcome back message. Okay, so that means that it is the first letter in this password will not be greater than M. So let's try something like D, right? And there's a match, welcome back. So it's greater than D, but less than M. So we're gonna go back and forth till we dial it down. So let's try F. It's not greater than F. Okay, let's go back one. E. Does that exist? And D, when we tried it, it is greater than D. So it's greater than D, but less than E. So the first letter should be E. Okay, so we could just go put the password E. That's the first letter. Now the problem here is we don't know the length of this password. Okay, so what we can do is we can use length. If I could spell greater than 1 to test how long the password is. So we can test if it's greater than 1, if it's greater than 20, 10, and dial it in until we find out the length of the password. So we can go test this out. Obviously it's greater than 1 because every password is, it's greater than 1, alright? So let's just try something like 15. Okay, we get welcome back, so it's greater than 15. Let's try like 21. Nope. So it's less than 21, greater than 15. Let's try 20. No, let's go down to 19. Yes. Okay, so it's greater than 19, but not greater than 20, meaning that the length of the password should be 20. So now that we have that, we can go back to doing what we were doing earlier until we find the password. So instead of 1, we'll switch it to 2, which is the second space in the string, and we'll test until we can find the password for all 20. But to speed this up, we could use a fuzzing tool, burp intruder, and I'm going to send this to the intruder. So we're going to clear all this space. We're going to add this around there to fuzz it, that input. And in payloads, we're going to add A, B, C, D, E, F, G, H, I, J, K, L. Okay, but we're also going to add numbers as well, because numbers also exist in passwords. And now we're going to go to options, grep match. And what we're going to do here is we're going to flag result items with responses matching these expressions, and we want it to match welcome back. So we're going to go and start attack. and you can see A is checked with welcome back, meaning that this is true. It is greater than A. B, C, D, and it's going through. And we're going to see whenever it stops ticking the welcome back, that is the one that we want. Hold on, I actually messed this up. Uh, guess not. Let me try that again. Okay, so it stops here at T. So it means it's greater than S, but not greater than T, meaning T should be the second letter of the password. So we go to there at T, and we just keep going through this over and over again until we get the whole password. I'm going to skip this because it's going to take a while because I'm using the community edition. So we have the entire password here, and so let's copy this and try it out. Go to my account, administrator, paste the password, and we got in. So takeaway is this application, or this lab in particular, the application is behaving differently based on the injected query, but not all applications will do that. It's not always going to have a welcome back here in the response for you to compare and test the responses. And so we're going to be looking at other ways to exploit a blind SQL injection, and I'm going to be going over exploiting a blind SQL injection by conditional SQL errors in the next video.